Hello everyone, welcome back. Today we have 1, 2, 3, 5 maximum profit in job scheduling. It is a hard problem. It says here we have n jobs where every job is scheduled to be done from some start time to end time, obtaining a profit. We are given an array of start times, end times, and profits where each index corresponds to that job, and we are to return the maximum profit such that there are no two jobs in the subset with overlapping time ranges. So if we choose a job that ends at time X, we will be able to start another job that starts at time X. So that is not considered overlapping. If we look over here, we see an example where the first job begins at 1, ends at 3. Another job begins at 3, ends at 5, and these are not considered overlapping, and that is a potential profit. However, if we see there's another job that begins at 3, ends at 6 with a higher value, so we return the maximum value that is non-overlapping. So to understand this problem, it's worthwhile to quickly review 3 topics: zip, sorted, and bisect. So I prepared these so that we can go over them quickly. Let's say we have some values. We have 3 arrays, okay? What zip does is it combines each nth values together. So zip alone will return some zip object, and in order to return them as a list, all we do is add list in the beginning. So this and this are the same. We just add a list in the beginning, and we can see what the zip represents, which is the 0th items, 1A and 1, the 1th index items, 2B and 2, and then the 2 index item, index 2, 3C and 3. Okay? And then to go over sorting, now let's say we have some other list that has 2, 1, and 3. Now, obviously, if this was sorted, it would be 1, 2, and 3. So why don't we do that? If we zip vals 1, which is this, with the other value here, along with vals 3, what we end up getting is the combined values at 0th index, 1th index, and index 2. But then if we add sorted and we use the key, so given that there are 3 values, we use the one at the 1 index, which is the middle guy, which is the other. Then when we do that, we get it sorted by the 1 index, which returns 1, 2, 3, and the others move around corresponding. Okay, and as for bisect, so it's really nothing more than given some values. Let's say we want to insert 2, 4, and this is sorted. Where can we insert 2, 4? Well, there's a 2, 3 over here, which is less than 2, 4. So 0, 1, 2, we can insert it at the 2nd or 2 index. Now, if we had just a simple 2, well, 2 is less than 2, 3, because this also has a comma 3, so we can insert it into 1. And then if we look at the example of 5, 5 again is less than 5, 4. So 0, 1, 2, 2 is where we would insert it. Same thing with 5, 3, because comma 3 is less than comma 4. Now, once we get to comma 4, which is equivalent to our existing value, bisect of bisect actually returns the rightmost value. There is a bisect underscore left, which returns the leftmost, but bisect returns the rightmost. So we end up returning 3, along with, if the value is greater than the existing value, then likewise we return the rightmost. Because this is a hard problem and we are using some of those, more not so common ones like zips and sorted, let's start with the code first, and then we'll go to the drawing board. Okay, so basically we want our jobs to be sorted. And we want it sorted by the end times. But before we do, actually let's start from inside out. We want to zip together the start time, the end time, and the profit. Okay? So we'll zip those together, but remember that gives us a zip object, so we want to return the list object. And once we do, from that, we want to sort by the end time ascending. So let's do sorted by, and maybe we can go here, sorted by, and what we're doing is we're using some key where each key is lambda.x, and we want to sort by the one at index 1. Okay, so now we have our jobs and it's sorted. The other thing we want is to keep track of some DP, and to initialize, we'll have the value. So if we end at position 0, or we end at some time 0, then our profit is 0. So this will keep track of the end and the profit up to that end position. Okay? And then now we're going to iterate each job. And remember, again, this is all already sorted by the end time. So for start and profit, so that might first start and profit in jobs, we want to get the position. So from the DP, we want to get the rightmost value, which does not overlap with the current value. And to do that, we can use bisect dot bisect. And remember, this returns the right insert position. And from where? It's from DP. And what position do we want? We want the one that overlaps the start. So we can do that by s plus 1, so start plus 1. But then we want to use the value before that position, so minus 1. So this will give us the index that we care about, which will be the pair containing the profit up until some end position, which does not overlap with our current start position. Okay, and then if the DP of that such pair and its profit, so the second value from the pair, if that plus the current profit, is greater than whatever is the last, so because this is DP, we are continually adding the best value. And so at this position, at this point in time, when we just begin, this is technically our best value. So if the non-overlapping previous ending profit plus the current profit beats the former best profit, minus 1 for the last pair, at one index, which is the profit, then we want to append the new best pair. And remember, once again, this is end and profit, so end is E, and profit is just this. Profit. We can do that as well. Let's do that. Profit. So we can add the current end and the current profit. Only if this beats the former best profit. Okay, and at the end, we can return the DP of the last pair, because every time we're only appending only if that current profit beats whatever is the last profit at the time. And then the last profit at the one index will contain the best profit. Let's give that a go. Oh, bisect. So this needs to be within a list. Okay. And submit. And there we have it. So this is pretty efficient. And now let's take one of these examples. Example 2 is a pretty good one to go through. So just visually, you can see that the best profit is, which is non-overlapping, is the 20 plus the 70 plus the 60, which returns out 150. And if we follow this logic into our drawing board, I drew it out here. Now, remember we started with the initial starting value, which is the dp, where the end ends at 0, so before anything begins. And the best profit up to that point is, of course, nothing, which is 0. And the jobs are already sorted by the n times. So it's sorted by the n times. This is the n times. And then we can take each job. So let's start at this guy. Okay, so we're on job number 1. And we say, okay, what is the insert point? The insert point is the bisect.bisect of the current dp, where the end, so first we want the overlapping position, which would be our current start of 1, 1 plus 1, which gives us a 2. When it's a 2, it would be considered overlapping. So 2 would be inserted here at index 1. So it would be inserted here. Then, so the I is currently 1, but then we want to go left of it. So if we do minus 1, that is 0. Okay, and the current profit, so current profit is at index 0, we have this dp at index 0, the profit there is 0, so 0 plus the current profit of 3, or the current profit of 20, which will equal 20. All right, so this is the potential current profit, and does this beat the former best profit? It does. So remember, when it beats the former best profit, we're going to add into the former best profit. Let's remove that. We're going to add to the former best profit. There we go. All right. We end at 3, because remember we're adding the end and the profit was 20. So let's add that here. All right, so we're done with this guy. Awesome. Now we're on the second job. The second job, if we try to find the insert position, it's 1 after the current start. Current start is 2. 1 after that is 3. 3 would be inserted here because it would be a standalone 3, and standalone 3 is less than 3 comma 20. So, but remember we want to take 1 before that, so it would be 0. So 1 minus is 0, and you can also see in this drawing, this is overlapping. So the current profit, which is going to be 0, 0 index profit is 0, plus the current profit 20. It does not beat the rightmost profit, so we skip. We don't do anything. Nothing to be done here. So we did not use this, nothing. We're on the third job. Now at this job, our start is 4. So to be overlapping, we want to take 5. And then 5 would be inserted at index 2, 0, 1, 2. But then we want to go left of that, so minus 1 would be 1, 0, 1. This is the value at index 1. Now, the profit up until this point, and you can see here 4, and then this ended at 3. The profit up until this point is 20. So the current potential profit is 20 plus whatever is the current job's profit, which is 70. So 70, and this ends up being 90. Okay, and the former best profit is 20. This does beat it, so we're able to add the current end, which is 6, along with the current profit, which is 90. Okay, and all right, so we're done with that job, and now we know that we used up this one, and we can move on to job number 4. Okay, job number 4 starts at 6, so to overlap it, we're looking at a 7, and then as 7 would be inserted at 0, 1, 2, 3. It will be inserted at index 3, and then minus 1, because we want to go left of it, is 2, 0, 1, 2. So this is the one in question. And then you can also check that, this starts at 6, this ends at 6, so this is perfect. Now, the profit up until this point is 90. The potential profit from this job is 60. And then if we add those two together, we end up with 150. Okay? And does this current profit beat the ongoing latest rightmost best profit? It does. 150 beats 90. So let's add that in. So we're going to add our new best profit, which ends at 9. It ends at 9, and its profit is 150. Okay, we're almost there. We're almost there. So now let's remove those guys. And we did use up this one successfully. We're on our final job. Our final job starts at 3. Okay, ends at 10, all right, with a profit of 100. So in order to be overlapping here, it would be 4, right? And then a 4 would be inserted here, 0, 1, 2. The index is 2, but we want to go left of that, so that's 1. And so 1 is here, and you can see from the drawing that if a job starts at 3, we can indeed take a job that ended at 3, because those two are considered non-overlapping. Okay, great. Now, so this is 1 over here. The profit up until that non-overlapping point is 20, and the potential profit from this current job is 100. So that looks like a lot. That's 100, which combined together is 120. Now let's see. Does this current potential profit beat the ongoing best profit thus far? Well, the best profit is always the last one, and you know what? It doesn't. It doesn't. So we don't add this to our DP, and once we're done iterating all of these, we can return the last pair's profit, which is at index 1. So we have the last pair, which is the end time, and the profit up until that end time, and we can return that, which is right over here. All right, I hope that was a little more helpful going from the code to the problem. So this is the code from start to end. And once again, this was 1, 2, 3, 5, maximum profit in job scheduling, a hard problem. Thanks so much. Happy coding. See you next time.